Hi everyone, I'm Professor Mark Williams and I'm your professor for intermediate algebra. Today we're going to be looking at sections 7.1 and 7.2 with an introduction to rational expressions. So diving right in, the whole part of section 7.1 is based on this simple idea that b is a square root of a if b squared is equal to a. Okay? This is very simply explained in the idea of if b squared is equal to a, then let's consider 5. 5 squared then would be equal to what? 5 squared then is obviously equal to 25. Right? So 5 is the square root of 25. Right? 5 is the square root of 25. But how do we write that out in simpler terms? Well, very simply, the square root symbol looks like this. Right? So the square root of 25, we would write 25 under that. The square root of 25 is equal to 5. Okay? Very simple. That's what square root is. You probably know that already, but that's the basis for the entire section. Right? So then you should be able to get things that you know, or this is called a perfect square. You should be able to have things that are very obvious to you. For instance, the square root of 9, right, is equal to, exactly right, 3. Right? The square root of 64 is equal to, that's right, 8. Right? So very simple, but I want us to break this down a little bit deeper now. Obviously, you probably already knew that the square root of 25 was 5 and 9 was 3 and 64 was 8. You probably already knew these things, right? But I want us to break it down and look at it in more simple, more general terms, okay? And the more general term is just looking at it, the square root, right? And instead of writing this as a 2, we're going to write this as an n, right? The square root of b to the n, the square root of a, right, raised to the nth power. The square root of a raised to the nth power. This n power is very important when you're dealing with roots, because you're probably very familiar with dealing with a square root. We were just talking about, for instance, the square root of 25, right? A square root is understood. The little 2 here is understood, and we don't write the 2 for 25. We don't write that, right? It's understood. But you do have to write it for all the other roots. Okay? And so, for instance, the cube root of 8, you have to write a 3 there, right? You have to write a 3 there for the cube root of 8. But what does that actually mean? Well, in the same way that up here, we said that if b squared was equal to a, then b is a square root, right? Then, looking at this, then if b cubed is equal to a, then this is a cube root. Alright? And obviously, for 8, 2 times 2 times 2, that's equal to 8. So that's 2 cubed is equal to 8. So 2 is the cube root. Right? 2 is the cube root of 8. Right? So you would denote this with this n. And you can put as many different terms as you want. Now, just think of this in very simple terms. Right? As long as we have different numbers and you have perfect squares, these are very easy to solve. But very quickly we're going to get to having more difficult numbers under this. And then looking at also different terminologies here and different roots. We're going to learn how we can deal with the different roots. Okay? But just for now, we know that a is raised to the nth power, very simply that if a is less than 0, then you've got a little bit of a problem, right? If a is a negative number on the bottom, right, then you know that we don't have an easy way to solve that. And as we move on in this chapter, we'll be able to solve this idea of what do you do when a is negative under the radical sign, right? But very simply, we know that in order to have a real answer, a real number, you cannot have a negative under the radical right now. And we'll find out what to do with that negative in a later section, but for now, you can't have that there. And so, let's look at the idea, because a few of your problems might ask you, what is the domain of a certain radical? Well, if we're saying that anything under the radical, whatever is under the radical, this right here, right? If we're saying that has to be, x has to be greater than 0, then when you're looking at that, for instance, if you're looking at what is, the square root, if what's the domain of x plus 2 under the square root, right? And remember, domain is the allowed x values. The range are the allowed y values. So what are the allowed x values? Well, you just simply say x plus 2 is greater than 0. You want x plus 2 to be greater than 0, so x then has to be greater than negative 2. All the numbers greater than negative 2. Well, how do I know that that's true? Okay, well, we can easily look at this. Let's say that x is equal to 1. So square root of 1 plus 2, that's the square root of 3. It's not a perfect square, so you can approximate that, but you know that that's allowable because you get a positive number. But what if I pick something that is less than negative 2? For instance, if I pick that x was negative 4. Well, let's put that under the radical. You get x is equal to negative 4 plus 2, right? Which is the square root of negative 2. And we don't know what to do with that, so that number is not allowed in the domain. Right, and that's sort of the gist of the very first section. I hope that was able to help you along in that one. But looking at section 7.2 is where I want to get to this sort of general formulation of dealing with roots. The general formulation of dealing with roots. And very simply put, the general formulation of dealing with roots is you write it in the term of a is a to the m over n. Okay? A to the m over n. And when we look at this whole idea of a to the m over n, that is the same thing as the root of a to the n to the nth power. Okay? A to the n to the nth power. That's the same thing. All right? And so, for instance, let's look at a squared. Okay? If we're going to look at the square root of a squared. Okay? Well, we should know that the square root of a squared is a anyway. But let's see how that works. Okay? So if we know that there's an understood, and I'll write this in red, if we know there's an understood 2 right here, right? If there's an understood 2, then when we write it in this term, then we get a to the 2 over 2. 2 over 2 is 1. So you get a to the first. Aha! So you get the same answer. So you can see how this works. I hope that this actually allows this to sort of fall in place for you to be able to understand how you can write this in 2 different ways. For instance, if we want to write something like the let's say that we want to write, a to the 7th, the cube root of a to the 7th. And we want to write this in this term that a to the m over n is equal to the nth root, or the mth root of a to the n. Right? So if we're going to write that, then this can be rewritten as a to the 7 thirds. Okay, we can write that as a to the 7 thirds. So looking at that as a to the 7/3, then you might not have any idea how we could actually solve a problem. For instance, if we came and then we were going to write this as the cube root of a to the 4th, divided by that. But look, we can actually rewrite this as a, right, to the 4/3. Okay? And one of the things that we'll learn is we're going to learn how to deal with a to the m over a to the n and learn how to manipulate those particular things. Alright, and so we've learned those things already. Let's take a look at some different properties of exponents, because that's really what's going to fall into place for us. When we look at some different properties of exponents, the first property we want to look at is the product rule, and that is, let's go ahead and erase this, a to the m times a to the n is equal to, right, a to the m, and use a different color here, plus n. A to the n plus n. So for example, right, for example, a to the 5th times a to the 3rd is equal to a to the 8th. Very simple, right? It's a to the 5 plus 3, which equals a to the 8th. Okay? That's called the product rule. Okay? The second one we're going to look at is the rule of negative exponents. Right? And that is that a to the negative n is equal to 1 over a to the n. Right? And the reciprocal of that goes along with it is 1 over a to the minus n is equal to a to the n. That's reciprocal of that. So, looking at this one, very simply, let's say that we have x to the minus 2. You'd simply write that as 1 over x squared. Right? Or, if you had 1 over x to the minus 2, you would write that as x squared. You just move it to the top or the bottom. Okay? That's the rule of negative exponents. The third rule that we want to look at, the third rule is look at negative exponents for quotients. Negative exponents for quotients, very simply, a to the b over negative n is equal to b over a to the n. B over a to n. How does that work? Well, let's say that we have x over y to the negative 3rd power. In order to get rid of the negative exponent, we would simply write that as y over x to the 3rd power. Very simple. Rule of negative exponents for quotients. The next one is the quotient rule for exponents. Right, it's very similar to this one. Right? The quotient rule for exponents is a to the m over a to the n is equal to a to the m minus n. A to the m minus n. Okay? Very simple example of this would be x to the 7th over x to the 3rd is equal to x to the 7 minus 3, which is equal to x to the 4th power. Alright? So that one's very simple. Just a few more here. The power rule for exponents. The power rule is a to the m to the nth power. A to the m to the nth power. Okay, that equals a to the m times n. Times n. Right? Times. That's different from the first one, the product rule. Alright, so looking at this, very simple example would be x to the 5th to the 3rd power is x to the 5 times 3, which is x to the 15th power. right? Some students really confuse this top one with this one. You have to be very careful to make sure you're able to keep them separate. Okay, so we've had the product rule, and we've got the rule of negative exponents, the rule of negative exponents for quotients, then the quotient rule, and then we've got the product rule, or the power rule. Now we want to look at what is the product rule for products. The power rule for products. In other words, how does the product rule work if you have something like a to the b raised to the nth power? What does that look like? How does that work? Well, very simply, a to the n times b to the n. A to the n times b to the n. Okay, so an example of that would be x squared y raised to the third power. All right, well, looking at that, you have x to the 2 times 3 times y to the 1 times 3, because this little y has a 1 there. Okay, so that gives you x to the 6th, y to the 3rd. All right, and as you get really good at this, you can easily see, looking at the power rule, 2 times 3 is 6, 3 times 1, 6 to the 3rd. You'll be able to just like that. That'll work this out. And then for you to have a lot of success in this class, you have to move quickly beyond these types of things. All right, and then the final one is the power rule for quotients. The power rule for quotients, so let's move that one up here. Power rule for quotients says a over b to the n power is equal to a to the n over b to the n. A to the n, b to the n. Again, simple example, x squared over y cubed raised to the 2nd power, right? X to the 2 times 2 is 4, y to the 3 times 2 is 6. The quotient rule, the product rule for quotients, okay? Very simple. And so when you're working through all of these, you need to be able to work each of these problems. Now, as we move on in this section, move on to the more difficult sections, you'll get more and more complicated and involved in this. But for now, that's sort of a quick explanation and introduction to rational expressions in 7.1 and 7.2. The next video will dive into section 7.3 and beyond for your next homework assignment. So I hope this is helpful, and of course you can always contact me, text me, or email me if you have any further questions about the content, about the course, about the homework, whatever you need. We'll see you next time.